Hello, welcome to Flip. So today we are on carboxylic acids, and these are the learning objectives for today. Carboxylic acid, is the fourth group of organic compounds that we will be learning in this whole O-level syllabus, with the general formula of C, N, H, 2N plus 1, COOH. And the COOH is the functional group. So with other organic molecules, we learned that we should not put the functional group together in front. So we should not combine this C with this C, this H with this H, etc. We should let it stand. We should let it stand alone. So with that being said, you can see that there are two oxygen atoms here. So this means that it's not a hydrocarbon, because hydrocarbon only consists of carbon and hydrogen. That's how they get their name. So let's move on to the properties portion, which is the same as alkanes, alkenes, and alcohol, because as the number of carbon increases, melting and boiling point will increase as well. Viscosity increase, flammability decrease. This is all covered in our previous videos. You can go check it out. Basically, as number of carbon increases, a molecule becomes bigger, and all these things will happen. Correspondingly. Let's move on to the naming. So the general formula for carboxylic acid is CnH2n plus 1 COOH. Let's put it here for a while. Let's start with the naming first. This is the same throughout all the organic chapters, in the sense that me eat peanut butter. This is the easy way to remember the first letter for each name. So it's the same also. Meth, F, prop, and bute. This will be the same throughout the whole organic portion. Then the behind portion, you just have to fill in its name, which in this case is methanoic acid, ethanoic acid, propanoic acid, and butanoic acid. So hopefully this is easy for you. Just have to memorize the front part. Behind part, you just have to put in what's the organic compound in question. Formula wise, this is a bit tricky, in the sense that the first one is actually HCOOH, because in this chapter, just in this chapter itself, you have to view this number of C in this case. So you have to see in terms of 0, 1, 2, and 3. What do I mean? Because if you really sub in number of C equals to 1 here, so C1, H, 2 times 1 is 2, plus 1 is 3. You should actually get CH3COH as the first one. But that's not the case, because you get HCOOH instead. So what you have to do really is to sub in 0 in this case, in order to fulfill this. I know this is a little weird, but it's really just for this chapter. The other chapters makes more sense. Just endure for this chapter. So with the rest, let's just write it out before I work it out for you. The final one, C4H9 COOH. So this is something that a lot of students will find like what is going on. It's like a bit confusing. Just really -1 for everything, and that will make a lot of sense. Let's try for ethanoic acid. If ethanoic is 2, but let's -1 to become 1. Let's sub in. So now it becomes C1 H, 2 times 1 is 2, plus 1 3 COH. So now it makes sense. So only for this carboxylic acid, do this -1 trick, and you should have no problem. So let's move on to the structure. Structure wise is quite simple. We always begin with a C, remember? And let's always end off with a COOH for this chapter. Then we can just fill in the empty space with a H. Oh sorry, this is not the case. I'm jumping ahead actually. Okay, so this one is is slightly weird because based on the formula, you only have COOH. And the front, you just put a H. Okay, so for this chapter, do not follow the usual step of starting with a C and drawing it continuously. Okay, only for this chapter, you start with the back portion, which is a COOH. Then you add on to the front. Okay, that will make life simpler for you. So in this case, COOH is at the back. I just have a CH3 to add CHH. Okay, and that will give me my CH3 COOH ethanoic acid. So for propanoic acid is the same thing. We start with a COOH. Okay, now we lack 2 carbons. So 1, 2, fill in the rest with hydrogen. Okay, and you can see that there are 5 hydrogens to be added. Finally, butanoic acid, COOH, 1, 2, 3, yep, with a H here. Okay, so sorry for the handwriting, okay. But if you count the number of hydrogen, it should make sense, okay. Which is okay, so you can count there are 7 hydrogen here. Oops, sorry. This should be 7 hydrogen. Okay, so to recap this weird chapter, you really have to begin with a COOH, then you add on the front of whatever that's remaining. And to actually get the formula, you have to take the number of carbon minus 1. Okay, so for example, in the case of ethanoic acid, I know okay, ETH means 2, but I must minus 1, okay, in order to sub in 1 here into the general formula. Okay, so my advice to you is begin with the name that you want. Okay, so for example, propanoic acid, I know it's 3 carbons, but I have to minus 1 to sub into my general formula. Okay, so it gives me C2H5COOH, but at the end, it should still follow propanoic acid in the sense that there are still 3 carbons at the end. Do you know what I mean? Okay, so 3, there's still 3. But you just have to do this trick is for the sake of COOH. Okay, because you have to take the carbon in COOH in account. Okay, and that's why you have to perform this trick right here. Okay, so give it a few practice and you should get more familiarized with this concept. Okay, let's move on to reactions. So reactions for carboxylic acid, there are 4. Okay, you have to understand that carboxylic acid are weak acids. Okay, so they usually react with weak bases, and they are able to react with all these carbonates, metals, and to form. And you will learn esterification later. Okay, let's start with the bases one. So this is really just memory work. Okay, acid. In this case we are using, okay, ethanoic acid. Okay, because there are 2 carbons here. Am I right? Inclusive of the functional group. There are 2 carbons, so it's ethanoic acid. Okay, you have to add an alkali. Okay, in this case is sodium hydroxide to give you CH3COO minus Na plus water. Okay, so what you have in front, it's a salt. Am I right? And this is obviously water. Okay, this is the neutralization, which means acid plus base. So you form salt and water. With carbonates, okay, it's like this, COOH, 2 of it, with, for example, a sodium carbonate, giving me 2 units of the salt with CO2 and water. Okay, so you can refer to our video regarding the neutralization, the salt, the acid and base reactions, okay, to understand how this salt forms. But basically, it's really just taking, for example, in this case, you're just taking the H with the OH to form a H2O. and the rest you just have to combine them. Okay, for example, I just draw it for you. This one with this one to form this one. Okay, so check it out. Check out our acid and base, the salt chapter. Okay, so you can understand what's going on fully over there. But this is just an overview. Okay, so I'll just simplify it. Okay, next is reaction with metal, which is really just 2CH3 COOH. Okay, so in this case, you notice that I'm using ethanoic acid again with Mg, which is magnesium metal. Okay, to give me the salt CH3COO, the whole thing bracket, 2 of it, magnesium plus hydrogen gas. Okay, so this one you have to memorize. With base, you get salt and water. With carbonate, salt and water and carbon dioxide. With metal, salt and hydrogen gas. Okay, so this is really just memory work. Okay, there's nothing much to unpack here. It's really just memory work. Okay, next one is a bit harder. This is esterification, which is really just combining with either alcohol or a amide group. But in this case, we are just using alcohol group to just illustrate the point. You can refer to my next video, which is the whole chapter on macromolecules. That will give an idea of esterification in detail. But now we are just showing the rough formula behind it and the conditions required. So really, it's just you have to do it at 55 degrees Celsius. Okay, you have to react it at this temperature in the presence of concentrated sulfuric acid, okay, which acts as the catalyst. Okay, you just have to perform in this condition. So this is just memory work again. How does it work? It's really quite simple. So basically, it's this. Okay, this is my acid. And this is an alcohol, for example. Okay, you can also react with amine, but we will talk about that later in the next video. Okay, but let's use alcohol for example here. To give me, okay, HCCH, double bond O, OCC. Okay, let me explain to you what is going on here. Okay, it's a bit confusing, but it's really not that hard. Let me assure you that. Okay, because you can see this is my ethanoic acid in the structural form. Am I right? This is my alcohol. So you learned these two chapters already. Acid and alcohol. Okay, now they're just reacting together. So it's really nothing special. Okay, they are not new concepts. Okay, so from the acid, you take a OH. From the alcohol, you take a H. And you combine them. What do you get? Water. Yes, that's right. Okay, water. And you can see that, let's draw a pink carbon. This guy. This pink carbon is also this pink carbon. Do you realize? And this pink oxygen bonded to the pink carbon is this guy. And finally, let's use green. This oxygen is this guy. So what do you see? After they lose this OH and H respectively, they are bonded together. And that is the whole point of esterification, to bind something together. Okay, and this is, we will learn in the next chapter. Okay, this is a ester bond. Okay, we will learn about it later. Okay, but this just to give you a heads up. And finally, the use of esters, there are three. First being perfume. Second, flavouring. Third, solvents. Okay, and that's the reaction for carboxylic acid. Finally, we move on to the formation of ethanoic acid. Okay, this is actually in your alcohol tutorial, which is the video that we talked about, one video before this. And really it's the same thing. Okay, so you can see that all chapters are quite linked in this portion. Okay, this chapter 11 for organic chemistry. In the sense that oxidation, okay, there are three if you remember. First one being with acidified potassium manganate 7. Okay, this is the first one you can do. Oops, there's a weird line. Okay. Second one you can do is acidified potassium dichromate 5. Okay. These are just chemicals, so it's just names that you have to memorize. Third one is actually in atmospheric air. Okay. The difference between all of them really you don't have to know. You just have to know that for oxidation, you have to use this sign. Okay, please remember. For example, in the case I take for ethanol, okay, ethanol, C2H5OH plus 2 square bracket oxygen to give me CH3COOH plus water. Okay, so it all comes together now. You can see that this is ethanol. This is the sign, okay, that we use to indicate oxidation. Please do not write oxygen. Okay, this is wrong. You have to write a square bracket or O, okay, to indicate oxidation. This, if you do this way, this is actually combustion, okay, which is not correct. So if you follow this way, you get at the end a ethanoic acid. Okay, with a water molecule. Okay, this is a water molecule. So just for final recap, ethanoic acid, okay, it's F, right? F means 2 carbon. Okay, and you can see that there are 2 carbon here. Okay, although in the front portion it's only 1 carbon, and that's why you have to do the trick that we do just now for 2C to become 1C. Okay, hopefully it's clear. If not, you can rewatch this video, and if you reach this portion, you should understand what's with this -1 trick. Okay, hopefully it's clear.